All right, thank you. So how do we turn off the lights? Is that going to happen back there? All right. And I've been told to push this button. Is that better? You can hear me? So today was my lucky day. All my oak allergies decided to introduce themselves to 2017 today. So hopefully I can get through this. I've been kind of sneezing all day. But as was mentioned, Bob and I have been working together since really going on 15 years now. And that collaboration, we had both been studying caves for at least, well, him longer than me, but I've been studying caves since I was in high school. I grew up in Southern Illinois, just west of Carbondale, and I got very interested in caves as a sophomore, junior in high school, and began in earnest studying caves as I was an undergraduate, and that's followed me through my entire life, even as I've moved around and traveled around the world. And one of the things that always comes up is that number one, people can't believe that we do that, let alone do it for that long. And number two is that there's really something more to it than, let's say, being an adrenaline junkie, some sort of science, or even the sheer possibility that you could have a career that was focused on something like the study of caves. There is in fact a word for that, and the word is speleology, or the study of caves. And that crosses many, many domains. Some of those are related to the geomorphology, or how the caves were created. Sometimes that's related to the biology of the caves, paleontology, archaeology in some of the caves, and so forth. And so what we were going to talk about tonight is studying the secrets of caves. You know, as caves, as you may or may not know, are completely dark inside all the time. No brakes on that. So you want to make sure you have the right lights. But it also provides you with a unique lens to look at these environments, many of which are undisturbed, some of which are highly contaminated. And so we'll talk about that as we go through. Please, if you have questions, feel free to ask, and hopefully we'll stay somewhat on time tonight. And so the first question that I ask is this exploration for the fun of exploration, or is it an expedition? And what the heck is the difference between those two words anyway? And what does that mean? For a lot of us, we've done exploration. In the last year, one of the big exploration type activities has been Pokemon Go, especially for the younger crowd. And this is a game where you have to leave the couch, go outside, and look for these little virtual characters. And so instead of sitting on the couch looking at their phones, we have younger people, sometimes older people, walking around looking at their phone. But the game's creators said specifically the reason they created Pokemon Go was to get people off the couch. And one thing you may not know about Pokemon Go is it was created by the same developers that built Google Earth. So they had a lot of experience in how to help people understand place, space. As was mentioned in the introduction, I spent my professional career working with the faculty and students at WashU to integrate those ideas into their research, whatever that may be. You know, Google Earth is one of those tools that everyone pretty much, it's ubiquitous, everyone's had exposure to it at some point. And you know, one of the things that's a truism about a tool like Google Earth is that you know, how many people did Find My House as the first activity in Google Earth? And so you're building a trust relationship with the tool, and you do those kinds of things in science as well. And that's one of the major differentiators between exploration, which we may do with a tool like, or a game like Pokemon Go. The other picture here is from the City Museum, where we're exploring spaces and seeing what's around the corner, and something like an expedition. Whenever we go on expedition, you know, we can even start to think about how might I make a living at this. We may have heard of, you know, hiking up the likes of Mount Everest as an expedition. Really, this, for the most part though, is a really, really expensive vacation. It's not so much a exploration. I think the permits now to just have a chance to hike up Mount Everest run about $55,000 just to be able to step foot on the mountain. So, you know, we may see this out of Hollywood and out of pop culture, that this is what an expedition is. But I would offer that an expedition is something very different than that. An expedition is not only going into these environments, but it's the notion of collecting data and bringing that data back out of that environment for further study. And that crosses, again, many, many different disciplines. Here we're looking at something called a remote operated vehicle that may be studying the deep ocean. But we also do this in caves. Now, drones and things like that have come a long way, but we're not quite to the point where we can have an autonomous vehicle fly into a cave any distance at all and pull information back out of that. And so what that means is that you have to go there. You have to occupy that space in order to understand that environment. And sometimes those things are very near the surface, and sometimes they are some of the more remote places that have ever been visited in the world. Does anybody know what happened on this day in 1970? You see the news story today? Today is the day whenever Apollo 13 said, "Houston, we have a problem." That happened on April 13th, 1970. I bring that up because a lot of people think of a place like space being the most remote place that one could possibly visit right now. And while that may be true of deep space, it's certainly not true of, say, the space station. There are many, many caves, dozens of caves, in fact, in the world, where you can get home from the space station to Earth faster than you could get out of that cave. Some of these caves are extraordinarily deep, well over 1 kilometer, well over 1 mile deep in Mexico and in Europe. Some of these caves require diving, and so you have a lot of logistics that have to go into just the mobility through the cave, and then you layer on top of that all the different scientific things that you might be undertaking at the same time and bringing data out of the cave intact. And it becomes a very complicated thing, not the least of the which is because while all that is a lot to handle, imagine doing it all in complete darkness, where you have to hold everything and you have to hold your clipboard and record the data, and you have instruments and you have a camera and you have all these different things going on simultaneously in the dark. And so it requires the development of kind of this specialized juggling skill of keeping all the information and data straight while not putting it or you in harm's way. If you go in the water, you need to hold all the good stuff up out of the water, and your body gets to go in the water as an example. So we have this example here on the left. This is a cave called Lechuguilla Cave. Lechuguilla is in the backcountry of Carlsbad Caverns National Park. And Lechuguilla is a premier cave in the world, but it's an especially interesting cave for science. And the reason for that is that things happen in Lechuguilla Cave that don't happen anywhere else in the world. An example of that is that there are scientists that are working right now on a possible cure for breast cancer based on organisms that were found in Lechuguilla Cave. Now that's a long way from saying we have a cure for breast cancer, but it was interesting enough for them to look at that in a way that they hadn't been able to look at anything else to date as it related to breast cancer. So caves present unique environments, and they're worthy of study on many different levels. In fact, many, many people make careers out of these kinds of things, studying things like microbiology all over the world. A lot of the research right now that's going into, say, how would we think about looking for life in a place like Mars is happening in caves because they are similar types of hostile environments. You may have heard the term extremophile. These organisms that live in the most extreme environments on Earth, and almost certainly anything that we find on a planet like Mars would be an extremophile if they exist. Not all of it is walking through a big, nice, pretty passage. On the bottom right here, you see cave scientists that are on their hands and knees looking for very, very small things in water and in the mud. So there's a lot of work that goes on at both the macro scale, understanding the larger characteristics of caves and cave systems, but there's an extraordinary amount of work that goes on at a very localized or very micro scale in terms of understanding the biology of these systems. So, luckily this is not a life-size photo. This critter is something that's known as the Illinois cave amphipod. And then Illinois cave amphipod is known from only 4 locales in southwest Missouri, or southwest Illinois. And in fact, they're in Monroe County, just across the river from here. And this thing is is around the size of a pencil eraser. It can be a little bit bigger than that, but just for reference sake, let's say it's the size of a pencil eraser. And realistically, if this organism disappeared from the Earth tonight, it would probably be no big deal. I say that because this happens to be a federally endangered species. And so there are special regulations that go on with groundwater protection, runoff into sinkholes, and things like that. But what we do know about the Illinois cave amphipod is that if the Illinois cave amphipod can't exist in the water in the cave, there's something wrong with the water. And so whenever we study and do science in caves, especially biology, understanding these kinds of things are our version of canary in the coal mine, if you are familiar with that analogy, where the miners took birds into the underground mine to detect bad air. Because a good many people in this world get their water straight out of the ground. And so I think something on balance, I could be off a little bit either way, but I think around 60% of the world's population still extracts their drinking water from groundwater. The biggest example of that in the US is a place in the South, Texas, called the Edwards Aquifer. And this is the aquifer that supplies water to San Antonio and Austin, Texas, San Marcos, and everywhere else. That's one of the last places in the world where they pump water directly out of the ground into urban environments without treatment. That doesn't mean that there aren't huge pressures on the Edwards Aquifer, because there are. Everything from supplemental phosphates that run off yards, so things like Scott's turf builder. Scott's turf builder will turn a beautiful spring milky white in no time flat. And so if you apply that to all the lawns, and this is one of the things that's happening in a place like Florida, and if you've ever been to Silver Springs or some of the big springs in North Florida, Wakulla, people use all of these chemicals on their yards in a place like Tallahassee. That runs off, goes into ground, and that's the equivalent of kind of mainlining drugs into your groundwater system. There's no filtration at all. All of that goes into the groundwater, and then we have a whole suite of problems. So what we're trying to do is understand those networks of systems, not to tell people to quit using chemicals on their yard, because that's not a battle that we're going to win, but to help people make informed decisions and to put systems in place so that those aren't happening in the way that they're happening now, and we can make better choices in our communities. So Focal Pole Cave that was mentioned, is the longest known cave in Illinois, and Bob and I are heading an effort right now with some cavers in the Illinois and Missouri, specifically in the St. Louis area, to document this cave in a more detailed manner. The original map for this cave was done in the early 1970s and 80s. I got involved in Focal Pole Cave in the 90s, and now we're resurveying that cave at a higher level of detail, because what we've learned from that is that the additional detail enables additional science in some of the areas like sampling and geologic understanding. So it's a labor of love. The cave is known to be at least 15 miles long, and we expect to find much, much more passage than that as we systematically explore every single passage in that cave. Some of those passages are big enough to drive a 18-wheeler in, and some of those passages are laying on your stomach in the gravel in the 55-degree water, kind of pulling yourself along inchworm style. We call that belly crawling. So we'll shift continents. This is a cave in the Galapagos Islands. The Galapagos, if you're not familiar with the geology of the Galapagos, they're volcanic islands. And so they are formed and continue to be formed by the same type of volcanoes we see in a place like Hawaii, called shield volcanoes. Shield volcanoes form lava tubes, unlike, say, Mount St. Helens and the stratovolcanoes in the Andes Mountains in South America are explosive type volcanoes. I see there's at least a couple of us in the room that are old enough to remember 1980 and the explosion at Mount St. Helens. Those are not the kind of volcanoes in a place like Galapagos. The volcanoes in Galapagos have eruptive cycles, but they're a much different type of material that's being ejected from those, and the lava flows down the slopes. and it can, under the right conditions, create what are called lava tubes. So we have a project right now in conjunction with colleagues in Quito in Ecuador to document all of the lava tubes in the Galapagos Islands. And so Bob and I was trying to remember, I think we're up to maybe 6 or 7 trips we've made down to the Galapagos to do field work and collect all this information. Because this information gives us insight into the Galapagos that we wouldn't otherwise have. The caves of Galapagos are some of the last undisturbed area of Galapagos. So it gives this lens that you can look through and see what the islands were like before man got there, before the whalers came in the 1600s, because they are undisturbed areas. In fact, many times when we go into caves in the Galapagos, no one has ever been there, not just in the last couple of years, ever. Whenever you walk into that cave, you crawl through that little hole into the next chamber, you can legitimately say that you are the only human being in the history of man that's ever laid eyes on that, that's ever stood in that spot. And that's one of the things that's really attractive for me for caving, is that there aren't very many places you can say that or do that on the surface of the earth. We've scaled the tallest mountain. People have gone to the deepest parts of the ocean. The caves truly are one of the last frontiers where no one has ever set foot before on our planet. So what we're looking at here is a giant tortoise shell. Giant tortoises are famous from Galapagos. In fact, we have at least one, I think, still here in the St. Louis Zoo. But tortoises live on the island. This is at the bottom of a 40-foot or roughly 10-meter rope drop into the throat of a volcano. The volcano is extinct, but nonetheless, it's the throat of a volcano, and there's a tortoise shell at the bottom. We don't know where this tortoise came from because these tortoises are no longer known on the surface. They probably did range in this area at one point before people showed up, but they don't anymore. So what you might be looking at here is an unknown species of giant tortoise that's gone extinct or been eradicated, most likely. But it also could be a modern day tortoise. And one of the challenges of working in a place like the islands is that there aren't ready-made laboratories there that can do the requisite DNA testing and things of that sort to figure that out. And these things have to be sent off to faraway places. Oftentimes, it takes months to get samples back. But this is a part of understanding this unique area of the Galapagos Islands and how they came to be what we know today. These are a few other photos from the Galapagos Islands. All of the photos of these things are either species that are unknown to science or they're undescribed species, meaning that no one's ever really taken a close look and written up the scientific record. And there are other things like these biomats that are on the walls and on the ceiling in some caves. Nobody knows what these things are. They may or may not be known to science. It could be something completely different. But this is not uncommon at all in a place like Galapagos to go in and find things like this. Now, Galapagos is kind of a outstanding place to work, but you can do these same kinds of things right here in Missouri. There are a number of species that have been discovered in Missouri. And one of the things about the cave environments, because they are so highly specialized, is that things that occur there may not occur anywhere else on the planet. It may be a localized species or something very, very specific to just a handful of locations, like our friend the Illinois cave amphipod that I shared earlier. So these are all things that await perhaps a PhD student or a master's level student that really wants to dig into that to better understand what's going on. Some of the caves we visit are quite large. This is a cave in Laos. This particular trip was sponsored by National Geographic. And the room that this particular formation is in, you could put the entire St. Louis Arch in this room underground. It is truly a remarkable cave. And in fact, the river that runs through this cave is about the size of the Merrimack River. It's quite a lot of water. In many places it's over 30 feet deep underground. And this cave hadn't been really had that detail level of documentation. Bob drew a map of this cave that was, how long is the map?
Just over 10 feet.
So the map is 10 feet long, and at that scale, how far is
20 centimeters, 20 meters to the centimeter.
To the centimeter. So that'd be 80, so almost 100 feet to the half inch. on that map. And so this is something that is in a very understudied part of the world. It's in a country in Laos, and this particular site in the field is only about 10 kilometers from the Ho Chi Minh Trail, so very close to Vietnam. And this area had been closed since the war in the 60s and early 70s. No visitors, no outsiders were allowed to go there, not the least of which was because of unexploded ordnance, bombs that hadn't been detonated yet. There's still a number of explosions each year. But this is a photo that made it onto the Nat Geo website. That's me for scale, standing in front of this formation. But of course it doesn't look like this whenever you're underground, because when you're underground, the only thing that you have to go by is the headlamp that you have with you. Now our headlamps are kind of industrial strength LED headlamps. And so you can get, I won't shine this in anybody's eyes, but you can get a pretty good beam and you can see things that are over 100 feet away with that. But it still doesn't look like that. On this particular trip, I think we used something in excess of 700 flash bulbs. Not electronic flashes, but the old, not made anymore flash bulbs, some of which were as big as a 60-watt light bulb. And so it takes that kind of firepower to illuminate a chamber like this. And it wasn't really until we got home or got to a laptop somewhere where you could look at it and say, oh my gosh, that's incredible, right? Because when you're in the cave, you see the earth tones and you see parts of that at a time, but you don't have the benefit of seeing the whole picture. And so there's a bit of guesswork sometimes that goes into cave science, especially understanding the larger features, is that you go and you do your best at interpreting what you've seen, but you may not know exactly what it was until you get back home, take a look at it and say, we're going to have to go back. We're going to have to do a better job of documenting what it is that we saw and encountered there. This is a cave, again, this is a cave lechuguilla. There's a person for scale down here. But these are called chandeliers. And these formations don't occur like this anywhere else in the world. I was in this chamber in 1989, 1990, and it had just been discovered. This room is over 1,200 feet underground. And it takes probably about 6 to 8 hours of travel time if you're in shape, one way, just to get there. And so a lot of the caves we camp in underground. This is another aspect entirely of working in caves. I think the longest cave expedition camp I've ever participated in was about 8 or 9 days in Mexico. And that, again, that camp was over 1,000 feet underground. So you're not just going to go out for some pizza. You're not just going to leave to get some fresh air, because it's quite an undertaking to move up and down those kinds of distances. Back to the Galapagos. This is Bob in this picture. Again, this is not something that it looks like. Yeah?
What's the temperature like down there? Is it hot or is it cold down there? It's going to be pretty hot down there.
You want to answer that?
Which cave are we going to talk about? I mean,
any cave in general.
A cave in general will take on the mean annual temperature of the place that you're at. The caves in Laos tend to be about 75 Fahrenheit. Caves in the Galapagos, 75 or maybe a skosh more. You're not going deep enough typically to get any gain in geothermal heat. If you're in the mountains, if you go to Montana and go into Great Expectation Cave, the air temperature and the water temperature in it are 35 degrees Fahrenheit. So there's some difference.
Well, I heard there's one cave with big crystal formations like 150 degrees.
Right. So you're talking about the mine at Nicea in Mexico.
The big
right, the big selenite crystals.
Yeah.
And that's not really a cave. That would be more like being on the inside of a geode.
Oh, okay.
And so it's a different process that formed that. But yes, it's very, very hot in there. In fact, that room is now underwater again because the mine closed and they quit pumping water out. And so it was flooded before. And in fact, the minute that they air filled that cavity, the crystals started deteriorating under their own weight. And so they're all subaqueous again and they're being supported in that fashion. So nobody goes in there anymore. But it's an interesting place for sure. And the point's taken is that the temperature there is quite quite a lot warmer. To kind of finish Bob's thought, caves here in the Midwest, because our annual average temperature is in, say, the mid-50s right now, the caves in Missouri and Illinois are going to be in that same range, which means the water's that temperature as well if you get into it. I don't know if you've ever stepped into 55-degree water that's neck deep, but it tends to take your breath away, is an understatement. So this is what the inside of a volcano looks like. This is in fact a cave or a volcano that's over 300 feet deep, straight down. And so we go in on ropes, we rappel into these caves, we're surveying and taking pictures here. But the blacks, brilliant blacks, reds, whites, and yellows on this are an artifact of the extreme heat and sometimes pressure that is present whenever this formed. In this particular cave called Triple Volcan, you can go all the way down past where you see here. It goes down another 30, 40 feet at the end of that room. And you get down there and the floor in the bottom of that pit is as flat as the floor in this room. It's a type of lava called pahoehoe. Pahoehoe is the real smooth lava. Is the real grabby stuff, typically boulders and things. But at the bottom of that is where the throat, if you will, or the main conduit of the volcano sealed off as the lava started to recede down from whenever this eruption occurred. So there again, you know, it doesn't look like that when you're there, but it helps us to understand many different aspects of the cave environment by taking these pictures beyond it being very cool to see.
What island is that?
This is on Isabella Island, if you're familiar with Galapagos. So the main island everyone goes to in Galapagos is an island called Santa Cruz. One of the only permanent settlements in Galapagos is there a little town called Puerto Ayora. If you were going to go on vacation to Galapagos, you would go there because there's not anywhere else to go. But then you have to take a speedboat that's 28 feet long, has 30 people on it, and cross 50 miles of open ocean. Sometimes the swells are like 6 and 8 feet. Not everybody makes it intact.
We should add, if you're an intrepid tourist, you can, at least the last time we were there, go to this cave. There's a guy running an operation where he'll take you down a ship's ladder and take you into this very chamber. It's not particularly safe, but you can do it.
So some of you undoubtedly have vacationed in places like Mexico, and you know that in those situations, money tends to speak. You know, no diving license, no problem. Come with us. We'll show you how to dive. And the same holds true in a place like Galapagos.
Those rocks, a lot of different colors, and they look pretty chunky. Did they fall from the walls, or were they brought in by water?
I'm not sure I'm smart enough to answer that question.
I will answer it as best I can. Most of the rocks that are there have fallen off the ceiling and walls. So the shape of this chamber has been modified by systematic collapse since the lava left. The colors are almost all various oxides of iron. When nature paints, he paints with iron, is sort of a general rule. There could be some sulfur involved, but I think most is just iron,
Right.
iron oxide.
Is that an active process?
No, the oxidation was taking place from high temperature gas coming off.
The materials coming off the ceiling?
Oh, yeah. It's an
Yeah.
active process.
Yeah, it's an erosional process over time. I mean, because this has a direct link, it's hard to see in this photo, but there's a hole right up here in the ceiling. And then back behind where the camera's at, there's the main entrance to this cave. And this is on the rain side of the island. So it rains almost every day on this spot. And so that water finally works its way through the overburden or the ground above that. And so it's, you know, it's drippy, it's all of those same kinds of things. And over time, that's going to work on the rock.
Does the rock just fall occasionally? Did you have a problem being in there? and
No,
rocks
not at
were
all.
falling?
I
Not
don't
at
think
all.
we experienced any rock fall
No.
while we were in that chamber.
Now the rocks on the ground are loose. It's like moving around in a gigantic boulder pile, but it's certainly manageable. This is in the same cave, and it's a close-up of the boulders, but you can see it's quite a bit different because there's all this white stuff on the rock, and we believe that this is a mineral called Aragonite. And Aragonite is what we call a secondary deposit. It's something that's growing on the cave after the cave formed. So this would be the same thing as like a stalactite or stalagmite here in Missouri, something that started growing after the cave was formed. And so this hasn't really been studied. I don't think anybody has said conclusively, to my knowledge, that it's Aragonite, but it certainly looks like all the Aragonite that we've seen in other parts of the world. But you know, it's a good example of something else that needs to be studied in more detail. Not everything in caves is small. This is most likely what is the world's largest known Rimstone Dam. And this is in the cave in Laos called Shebang Phai, where the Merrimack River-sized river runs through the cave. In the rainy season, there's evidence that all of these pools fill completely. And in doing so, they provide a unique environment for things that live in the cave. You may have noticed there was an announcement this week that they just discovered a new spider species in Mexico that's roughly the size of a softball. You know, so that's a pretty big spider. We encountered in this cave a spider called huntsman spiders. Huntsman spiders can get up to 25 centimeters across in Southeast Asia. If you're unsure how big that is, it's about the size of that clock on the wall over there. Right? And these spiders can jump about 2 meters. So over 6 feet at a time. And they're mildly poisonous. Now, I share all that with you. Bob and I didn't have the benefit of that information when we were in the cave. We didn't find that out until later. So, you know, sometimes it's probably better that we didn't know that. What do they eat? A variety of things in the cave. The individuals that get that large, I don't know if they have a preference for one thing or another. Yeah.
Not cavers.
Not cavers. But we also don't have no one was brave enough to put their hand close enough to it for scale to take a picture. So all the pictures we have of them are just the spider by itself. And you don't really have a sense of how big it is. But this is a very interesting place. And I put this in because not everything that you study in a cave is small or localized. This feature is the length of a football field long. Some of these things are quite large and they're formed by very, very powerful processes. Not everything in a cave is delicate, although many things are. And as a general rule, you should not touch things when you're in a cave. Here's one of the formations that's just on the side in this cave. One of our guides, one of our logistical support people, Mr. Ng, is here for scale. He's maybe a little bit shorter than I am. But you'll notice that everything behind that is black. And that's not because of Photoshop or anything like that. It's that it's hundreds and hundreds of feet to the next wall behind that underground. It truly is this auditorium-sized room underground. Shifting gears a little bit, I'll talk a little bit about technology underground. This is a project that Bob and I undertook at Mammoth Cave National Park. Anybody been to Mammoth Cave down in Kentucky? Great. Mammoth Cave is the longest known cave in the world. Right now, Bob happens to be the chief cartographer. I'm the chief GIS person for Mammoth Cave for all the cave survey data. And we've documented over 400 miles underground in Mammoth Cave. And there's no end in sight for that. So the next closest cave to that is about half of that length, and it's underwater. So, you know, for now, Mammoth is the longest known cave in the world. And the Park Service approached us a couple, maybe 5-6 years ago now. They said, we want to build a new visitor center. And if you went to Mammoth Cave in the past, you probably were met with a very utilitarian 1960s, almost looks like the post office style visitor center. And that was a period of architecture in the government. And now they're building very elegant, like exposed wood beam buildings and stuff like that. And they said, what we'd really like to have is this 3-dimensional model that will be a centerpiece of our new visitor center. Would you help us collect the data to do that? And Bob and I put our heads together and started thinking about how we might do that. And we decided to use a new type of technology called terrestrial LiDAR. And really what these instruments do is they use lasers to collect extremely detailed data about their surroundings. And so Bob and I spent about 60 hours, 80 hours underground collecting data on the historic tour trail in Mammoth Cave. And so this is about how long is the tour?
2.25 miles.
2.25, I was going to say 2 or 2.5. That's a big loop that goes out through the biggest passages in Mammoth Cave. And then we built a three-dimensional model out of that. It was turned into an animation. It was included in the movie. If you go to Mammoth Cave now, you'll see the results of this data collection. But it goes far beyond that for science, because we can also do things like allow people remotely to interpret the cave. You know, if we were looking at a school in, say, New Zealand that wanted to visit Mammoth Cave, they're not going to jump on a school bus and drive to Kentucky, right? And so what we can do is build a three-dimensional model where the kids or the students can be immersed in the cave at this very, very high level of detail, and they can interact with it. Some of the tools that we experimented with were even things like game engines, where you could have multiple people in the same environment at the same time, even though they may not be in the same physical place. You say, well, that's cute, but why would I want that for science? I might want that for management of the cave, to understand things that need to be done and make plans and do estimates. Mammoth Cave is like every other cave in the National Park Service system. There are no handicap tours. And so if somebody was mobility restricted, you would be able to allow them to visit that part of the cave, even with an interpretive representative from the park, a ranger, to work with them on that. Beyond that, it has a lot of implications for understanding three-dimensional space. When we make maps, even in caves, most of what we do is two-dimensional. We map what's on the floor. So I would draw all these chairs, I would draw the aisle, I would draw the walls. What I'm not going to draw on that map probably are the lights and the projector and things like that. When you collect data in 3D, you can then add that third dimension to everything that you're collecting. Why would that be important? What lives on the ceiling in caves? Bats. All your bat habitat is up there. It's not down here. And there's not very much known actually about how many bats fit into a specific area. And a lot of the research that we've done more recently is trying to characterize how many bats can fit in all these little cracks in the ceiling, so that we can improve the methods that we use to count bat colonies. This is really important because, as many of you undoubtedly know, the bats are being decimated right now by a disease called the white nose syndrome, which is a fungus that grows on their snout, and then they wake up in the winter time when there's no food, and those bats will die. Very, very few survive that. And so we're trying to improve rapid ways to minimize disturbance, improve data quality, and support the biological research that's trying to save the bats. This is us scanning I only put this in because I thought it was a cool slide, but these green lines that you see going up and down, those are the actual laser beams that are collecting the data. So this bit here that's on the tripod, it rotates around and it collects that data in a radial fashion by sweeping around. Then we put it all back together in the computer. So one of the other things that we'll do in caves sometimes is to go in to document them, because areas are under dramatic development pressure. This cave is a cave called Caverns, and it's on the Mayan Riviera, about 100 kilometers. It's about 100 kilometers south of Cancun, if you've been to the Cancun Mayan Riviera place. Unfortunately, that main highway, if you've ever ridden in a bus or driven along that highway, the main highway is only about 6 feet above the roof of that cave. It goes underneath the highway. In fact, these two piers are holding up a pedestrian bridge that goes over the highway. They drilled through the cave. Somebody went down in there. These are forms that are made out of chicken wire and plywood that's been soaked in water and then filled the caissons with concrete, and they built a bridge on top of that, right? So whenever you're in this cave, you can hear cars hitting their brakes on the pavement above. It's not a matter if this is going to collapse. It will collapse. Caves collapse all the time on the Mayan Riviera. But one of the things that's very important about this, as I move to the next slide, is understanding how the caves relate to the surrounding development. And so over here we have a major golf course development kind of thing. Here we have the major road, and then you can see that there's cave underneath all of this road. The reason for that, it's not coincidence, the reason that happens is that they build the roads on the quote-unquote high spot, which in the Yucatan means this much higher than this. And that's an old beach ridge. That's an old place where the ocean level used to be up to. So they built a road on that, but that's also where the caves form, is in the paleo beach ridges. So you have this unfortunate correlation between the road and the cave environment. And while that's a problem for transportation, realistically what's going to happen is that'll collapse some night, probably with a truck or a bus or something like that. There will be people that get hurt, hopefully not killed. Overnight they'll come in, they'll fill that up with bedrock, and they'll pave over it and call it a day and start running trucks up and down the road again. And that's the way it happens, unfortunately, in the developing world. What's more problematic and what's much more difficult to understand about this is that we're starting to see evidence that these caves, so the ocean is just over here, not even probably a quarter mile over here. And one of the things about the Yucatan, if you've ever been there, is that you could roll a quarter all the way across. It's perfectly flat. And as a result of that, it's highly vulnerable to hurricanes, hurricane surge, whenever the water's being pushed ashore, except that never happens. And the reason that it never happens is that we believe the cave systems are the shock absorber for the storm surge. So as the waves, as the water's being pushed towards the coast, it's backfilling in all these caves that are underneath the surrounding terrain, right? What happens whenever you start to collapse caves is you start clogging up the plumbing. And there's nowhere for that water to flow anymore. And so inevitably what's likely to occur is this keeps happening over and over again up and down the coast, is the next hurricane there will be more exasperated coastal flooding. The next hurricane there will be even more. Until you start having real damage done beyond the winds and things like that of a hurricane, you'll have areas that are fully inundated along the coast of the Mayan Riviera because there's nowhere else for that water to go. You've completely clogged up the plumbing of the coastline. This is a well. You can go down this well 20 feet and swim in the drinking water. That's the direct connection that I was talking about earlier. There are places in south of Austin where I personally have rappelled down and gone swimming in the Edwards Aquifer. That's the same water that's going to come out of somebody's faucet. And unfortunately, in a place like the Edwards, the first time anybody knows something's wrong with that aquifer is going to be when about 85,000 people in San Antonio try to check into the hospital because something was wrong with the water. The only thing that overcomes that right now is just the sheer volume of the aquifer. So you may have heard the phrase that dilution's the solution to pollution. And there's some truth to that and whenever you're dealing with these massive aquifers. But the caves, especially here in the Midwest, we don't have that luxury. Most of our caves are far more sensitive to the contaminants that we subject them to. So it's really important to understand those linkages and engage in responsible land use and responsible land management. Some of the caves are big. This is back to Laos. This is kayaks going into the cave. And this picture doesn't do this cave justice. I don't know what could be done about that. Because the cave you're looking at right now, you can fly a 747 about a quarter mile into that cave and not hit any of the walls. That's how big it is. The entrance, where just ahead of where the camera is set up, this is almost 500 feet tall right here. And in fact, this part of the cave is over 1 kilometer away from where this camera is set up. And you're looking into the cave for 1 kilometer, and it's still daylight and it's still that big. So this is a very, very impressive cave. And this is a cave where to get from one end to the other, you go completely underneath a mountain range, coming up on the other side. It's, is it 5 or 7 miles one way?
5 miles.
5 miles, 7 kilometers, I guess. 5 miles one way, and you have to portage your boats over house-sized boulders 9 times to get from one side to the other. Again, doing it all in the dark, all in the water, with sometimes class 2 and class 3 rapids. This is one of my favorite passages in this particular cave, but it's several hundred meters to the person down there with the flash bulb. And this cave is, or this portion of the cave is well over 100 feet tall, just straight as an arrow, very spectacular passage. And you can get a sense of how clear the water is because there's no development around this cave. It's completely undisturbed. In fact, this is in what we would call a wildlife preserve or almost a national park. They have a different terminology for it, of course, in Laos. Not everything you see in the cave is warm and fuzzy. These guys are harmless, but man, they scare you every time you see one of them. Not only because of their looks, but it's probably the fastest moving thing that I've ever encountered in a cave. And these are pseudoscorpions, and they are completely harmless. They're very small, but they can get this big too. And I can't even tell you the number of times, because when you're making a map in the cave, you're really concentrating on what you're doing. And one of these things will zoom past your book or across your arm or something like that, and it takes about 10 minutes to get your wits back about you to go back to work, because you're not sure what happened in that area. One of the things you'll notice about this critter, though, is that it has pigment. And pigment means that at some point it's exposed to sunlight. Not everything in the caves fit that bill. Things that live underground their entire lives, the troglodytes, lose the pigment for the most part. So this happens to be a smaller one that's lost all of its pigment. It has no eyes anymore, and it will live its entire life in complete darkness. In fact, it's probably annoyed with us that we're there, and because while it can't see the light, it can feel the heat and things like that, because those senses have been heightened over the evolution. And so not everything we do is just walk into the cave. Here we're looking at some very technical work by, that's me standing on the right side, getting to rappel down into this pit, and one of my colleagues, Rick Haley, who's a specialist with vertical rigging and ropes, that's also our safety person on expeditions. Rick is double checking all my gears so I don't fall down the hole uncontrolled. Always good to have somebody check everything out, no matter how good you think you are at something, whenever there's life safety issues involved. So we try to practice that each and every time that we go down a vertical drop. You can see there's a lot of specialized gear here that allows us to do that safely. I have a safety on here. I'm attached to the rope here. I have my harness on, and then I have some other safety gear here as well. And the reason that this yellow strap is here is to keep all of my stuff and me from swinging over and hitting those rocks, swinging sideways whenever I go down the rope. Other caves require even more specialized gear. This is a cave called Cueva de Luz in Mexico. And the reason that these cavers are wearing breathing apparatus is because this cave has sulfuric acid in it. And in fact, there was a lot of research that's been going on. The things that they're looking at here on the wall go by the very lovely name of snottites, because it looks like snot dripping off the walls, but all of these things have high levels of sulfuric acid in them, and you can only be in this cave for limited amounts of time. Again, we talked about the dilution being the solution. You'll notice that they're wearing shorts and wading in the water. There's enough water circulating through the cave that you're not wading around in sulfuric acid, but it's pointless to try to wear pants or anything, because anywhere the acid's going to get on your clothing, it's going to eat holes in it. So there's some really interesting things happening in this cave that cavers would like to better understand as well. And then as we finish up, let's say a little bit about cave diving. This is one of my friends and colleagues in Mexico. His name's Herman, and Herman is in charge of the archaeology in Cozumel and the Mayan Riviera. Herman's also a cave diver, a very good cave diver. He's trained thousands of other cave divers, but he's an underwater archaeologist. And so he makes maps not only in caves, but in caves that are underwater to better understand the cultural aspects of when the Maya lived in the Yucatan Peninsula. And so while I may help Herman carry all of his tanks and scuba gear into the cave, that's not something that I'm cut out to do for a variety of reasons. I have problems clearing my ears and things like that. but it's also not something that's ever really particularly interested in me. I have a lot of friends that are cave divers, and I support them where I can, but it's not for me. So, one of the things you have to learn whenever you get involved in caving, especially cave science and cave expeditions, is really kind of looking inward and being self-aware of what your own limitations are. Because whenever you exceed your limitations on the surface, that's one thing. Maybe I went for a run or a hike that was a little bit too long, and I had to hike back, or I ran out of water or something like that. Whenever those things happen in caves, the problems are compounded immediately. And those things can lead to injury and even loss of life in some cases whenever you get in over your head, so to speak. And so, knowing that about myself, I think has really served me well to say, you know what, there are some things that are okay that I don't do those things, where others may feel completely comfortable. There are many other things that I do in caving that maybe her mom would never think about doing. So it really is a community of collaborators that it takes to document the variety of caves that the planet Earth has to share with us. So I think with that, we're nearing the end here. This is again back to the Galapagos. This slide is Bob sitting up here watching me make the first descent down into the throat of this volcano. We happen to be there at midday when the sun's overhead. If you know your geography, the Galapagos is right on the equator. They get 12 hours of sunlight and 12 hours of darkness every day, year round. So whenever you're there in the middle of the day, the sun's coming straight down. Get this beautiful sunbeam that's almost the width of this room. It goes right down the shaft or right down the throat of that volcano. And this is why we go. We love to understand these unique environments. We love to bring that data back for understanding, to enable further research, science, but also for management and understanding, to give information to developers, to people that want to establish parks and things like that. And we bring all that together, and it's interesting enough, at least for Bob and I, that we've been doing it for most of our lives, and we'll continue to do so. At least I will.
And let me point out something about this picture. This is a nice, beautiful, benign-looking picture. But the reason I'm sitting there instead of going down there to help him is that's a 40-degree angle of repose slope. And if I move from where I'm at, I kick rocks down and they fall on his head. And so you go down that one at a time because even going down it, you're risking falling off the cliff that's at the bottom of the slope.
Yeah, it doesn't do it justice, but all the brown stuff you see there is gravel. It's just cinders. And so it's like a steeply sloped gravel pile that you have to carefully pick your way down until where I'm at right there, the cave bells out and it's almost 50 feet straight down to the bottom from there, to the rock pile that you saw earlier. But I think that is the last of the slides. So thank you, and we can answer any questions you might have.
Why flash bulbs? Why not use digital sources of light or regular light sources?
So those photos were taken in what, 2007, 2008? 2008, and the electronic flashes weren't quite what they are today. I think that they still don't provide the same amount of light that the old bulbs provide.
Where do you get them?
You scrounge. You go to antique shops, you go on eBay, and not just here in Missouri, you do that globally to find old stashes that have been forgotten. Sometimes you pay a premium for them. But we used over 700 flash bulbs. In fact, somewhere in one of my slide decks, there's a photo of it, of the pile of bulbs. But the real reason that cave photographers like them is that they find the LED light to be very cold in the photos.
But you're using flash bulbs for digital photographs, not for film.
Correct.
Yeah, okay.
Let me add to, I'll just repeat what Dave Bunnell said.
Yeah.
With an electronic flash, you get about 1,000th of a second light. Thing on and it's off. Flash bulb will burn for 3 seconds. You integrate all that light and you get a huge amount more light out of a flash bulb than you get out of an electronic flash. And they're also warmer tone.
Yeah, it's a different wavelength of light. I think there was one up here, and then we'll come in the back.
All right.
Excuse me, are either of you familiar with the formations they call Mogotes in western Cuba?
Are those, I think those are in some of the flank margin caves, the caves that are along the coast?
No.
Are they in the interior?
Inland quite a ways. It's kind of a peculiar thing where it's levels of caves with stalactites.
Oh, yeah, yeah,
Up or down. And how does that form?
yeah. So typically, the way that would happen in Missouri, for example, there's actually an area in Onondaga Cave where you can see that. And you get these artificial shelves that form, and the way that's happening is that most likely, and add to this where I go wrong, but the water level was at different points in the history of the cave. And so you get things that form at different various water levels, and whenever the cave then is evacuated, the water's evacuated, it looks very, very odd because you have these strata of cave formations that seemingly defy explanation. But if you can put all that water back in there at the different times in the history of the cave, it all lines up quite nicely.
It forms these peculiar rounded
Yeah.
hills and valleys.
Right, and so you can get some of those things we see now in Mexico that manifest as like calcite mounds that are underwater. It's just pulverized calcite. And sometimes when you walk in it, you know, it's deeper than your boots. Calcite's really sharp whenever it goes down into your boots. It gets your attention really quickly. It's like having cockleburrs or something in your boots. So I agree that they're very odd things, but whenever you can when you can roll history back and look at the conditions when those things formed, the puzzle starts to come into focus.
Thank you.
There's some hands in the back. We'll work our way back here.
What Missouri caves have you guys researched?
Bob's list is a lot longer than mine.
I started caving a long time ago when a cave called Crevice Cave, which is the longest cave in Missouri down in Perry County, was being explored out. And there's a long list of them since then.
Yeah.
It's now just past 30 miles in length, Crevice.
But some of the longest known caves in the world are in Perry County, Missouri. 4 of the longest known caves in the world are in Perryville, and there's a whole host of caves around the state that are in that same ballpark in a variety of places. Almost all the known caves in Missouri are south of the Missouri River, and a good many of those are in southeast Missouri and southwest Missouri. Some in obviously the Ozarks where you have the current and Jack Fork rivers and things like that. So just think about that geography in the blue.
Yeah, I was going to ask you if you've ever worked in that Tumbling Creek Cave. Is that still a going operation down there?
In Pro Tem, the Tom Ailey's cave. Yeah, so yeah, Tom and his wife still run the Ozark Underground Laboratory. And he owns a consulting business that does dye tracing all over the world. And he's a world-renowned dye tracer. Tom still owns, as far as I know, he owns the world record for a positive dye trace. He dye traced a sinkhole that was north of Salem, Missouri to Big Spring in Van Buren, which straight line distance is almost 60 miles. And so what, there are even Dr. Chris, who's with us tonight, and others have looked at the water that comes out of the springs, the deep circulation springs in the Ozark. And a lot of that water is quite old. It's older than even I would have imagined, in some cases perhaps approaching 100 years old. So that water is staying underground for a long time. And I'm not sure anybody that's being honest with you could say that they fully understand the deep springs that are in the Ozarks and how they came to be and why they are the way they are. There was, I think, in the back, and then we'll come up
I
here.
have 2 questions. One, I'm sure you're pros at it now, but when you first started caving, how did you deal with any, especially on the extended trips down in caves, how did you deal with the anxieties, the claustrophobia, any sort of mental things that might happen?
Yeah, I can only speak for myself, but I've never experienced claustrophobia at all. And I've reflected on that at different times over the last 35 years. And I think some of that is in part because you can't see the total picture whenever you're in a cave. You just have your headlamp. And so all you can really see and all you can really understand is what's in your immediate vicinity. You know, like some of those drops, like that drop, I'm concentrating on what's in front of me. I'm not focused on the fact that if I turn around and look, it may be 200, 300 feet of open space right behind me, right? But I have to trust in my gear and I have to concentrate on what's in front of me. And in doing that, you're not allowed to think about all these possibilities of what could be, right? And so your mind tends not to wander. You tend to be very focused on the task at hand, whether you're moving through a crawlway that's maybe half full or more of water, or you're working on ropes, or you're in a very small crawlway. That's not to say that you don't have times of urgency where it may be tighter than you want it to be or something and you're squeezing through, but those are not things that have really ever bothered me. Bob's got some stories about being...
3 weeks ago, I was stuck for about 5 minutes. And I didn't have a real sense of claustrophobia, but I really was quite annoyed with myself for having crawled into that place I was in. The fact is that if you do caving for a long time, you don't really have a very strongly developed sense of apprehension and fear of what you're doing, and it's more a sense of wonder of the beautiful things you're seeing that stimulates you, and you don't worry about it. I mean, it's just a different group of people.
It's definitely a mindset, because there is no small amount of hardship to get to the good stuff sometimes. And you have to be willing to put up with that and go through it to get there. And that's certainly not for everyone.
Thank you.
Yep.
So to go backwards a little bit here, how does one determine the age of water?
Of water?
Yeah.
So there are different techniques to do that. I think a lot of it involves looking at the isotopes that are involved in the water. I'm certainly not an expert on that. So that's about all I would say about
We
it.
will defer the answer to that question to Professor Chris.
Yeah, maybe talk offline to Bob, and he can
Answer.
fill that in. We have one back here, and then we can come back up.
With increased CO2 in the air and climate change in general, is that affecting the rate of cave formation and the dissolution, dissolving of it? There's more CO2, so the air is getting more acidic.
I think there's probably not enough data to really say. When you take into account the age of some of the caves, having formed over, the caves here in the Midwest, many of them were filled with sediment during the last period of glaciation. Some of that sediment's still in the caves. So you're talking about a long arc of understanding the broader processes of cave formation, and having even a couple decades of data is just not even the blip on the radar to be able to understand that. You can look at the chemistry and make some inferences to say, yeah, this is going to get more accelerated, or no, it's not. But you can also look at things like the temperature of the water. And the warmer water, as I understand it, tends to be more aggressive than colder water. So that's why whenever you go to somewhere like the tropics, say Costa Rica or something, and see these enormous cave passages, you have to consider the climate in which those caves formed, which may also be speaking to some of the larger caves you see in different parts of the world that it might be cold now, but that cave may be old enough that it was formed whenever that part of the continent was in a warmer climate or something.
One thing, you guys are doing the underwater cave diving?
What's that?
You're doing the underwater cave?
Not for me. No, I like being alive.
Yeah, that's fine.
What he said.
Is the limitation of the use of drones basically that you can't get the radio signal through all the rock?
No, it's just that the caves are very irregular. There have been some efforts done in big dome passages. So you could imagine flying a drone in a place like Marvel Cave at Silver Dollar City, for example, if you've ever been there and seen the big, in fact, I think they put a hot air balloon or something in there as a gimmick a while ago. But the caves are so irregular in terms of the diameter of the passage, the character of the passage, that it's just not a productive use of time yet. Now, as drones maybe became more self-aware or autonomous, that's a game changer, and you can miniaturize that technology. You bet. Those are things that are exciting, that are out there on the horizon for technology.
Yeah, little radar signals that they could navigate passages, and then they could be mapping it with lasers
That's right.
along the way.
That's right.
And you could just turn it loose, and, you know,
Yep.
get months of work done in a
Hopefully,
couple of days.
hopefully.
Yeah.
I'm all for it. Yeah.
I was just wondering, those caves you were talking about in Perryville and that, is there any way, like, lay people could see those? Is there a website where you sometimes get tours, or?
So yeah, there are a number of caving clubs here in the St. Louis area and around Missouri. You want to say anything about that, Derek?
So I'm resident of Merrimack Valley Grotto. Look on our website, merrimackvalleygrotto.org. We're one of the bigger caving groups in the region. We do a little social caving, and we do what you call expedition or project caving. So if you look us up on merrimackvalleygrotto.org, that's
Right.
just you can get a taste of it. So.
Yeah, I didn't mean to put Derek on the spot, but the point is that there are organized caving clubs, and whenever you get involved with those clubs, it'll really open up your opportunities to go and see some of those places that most people are not going to get a chance to access.
And you'll also get access to the skills, the expertise, the equipment that you need to
Yeah.
go safely. When I started caving in Perry County in Crevice Cave, it wasn't uncommon for us to go on a caving trip into the crevice and have to rescue a party of local people who had gotten down the climbs and down into the mile of passage that they could figure out where it was, and didn't have either the light or the stamina to get themselves back out. So we'd go in a half a mile, you'd find people sitting on the side on a ledge crying and with their lights out and no way to get out.
Yeah.
So you take them back out of the cave.
Yeah, I started caving in 1987, and even in the 1980s, the primary source of light was a carbide lamp. And so, you really had to learn how a carbide lamp worked, because you are farther from the entrance than you can afford to make a mistake. And so you learn how these things work inside and out. You learn how to repair them when you're in the field. You know what the common failure modes are, how to repair those on the spot with what you have, carry backup parts, all those kinds of things. Because the consequences are final if you make a mistake in those situations. The gear that we have now is so much nicer than even stuff that we used back then. Is there any other hands? Oh, one more maybe. Last one.
What's known about all the caves that exist under downtown St. Louis?
St. Louis is a phenomenal place with regard to the cave development. I know not of another urban area the size of St. Louis that's built smack dab on top of a sinkhole plain the way St. Louis is. And that's both fascinating and sad in many respects. Many people don't know that just west of downtown St. Louis in the early 1800s there was a spring-fed lake called Choteau's Pond. And Choteau's Pond, by early accounts, had multiple springs that dumped into it with enough water that there was a year-round channel that ran all the way to the Mississippi River. Choteau's Pond was filled in during a cholera outbreak in the 1840s. Where did all that water go, and where did it all come from? Now there's some limited understanding of the caves under St. Louis, but if you really want to get an idea of what it was like, especially say in South City, St. Louis, I urge you to go to the History Museum and look at something called the Compton and Dry Atlas of St. Louis. And Camille Dry fashioned an isometric or orthographic, if you will, view of St. Louis. And it is absolutely amazing to see how many sinkholes there were in the south part of St. Louis. In fact, there was a commercial cave called Cherokee Cave that was operated until they built the Interstate 55 that collapsed part of that cave. Undoubtedly, there are still remnants of caves like Cherokee down there. There are other caves that have been associated with things like the brewery. There's stories of a cave that's under Union Station, and so on and so forth. But while you can find remnants of some of these things, there's very little of it that's left that's intact. Instead, what you get are stories of people who say, why did my basement keep flooding? Well, because that used to be a sinkhole, and that's where all the water goes whenever it rains, whether you fill it in or not. And so the understanding, I think, of the caves under St. Louis, there's a book even called, I think, The Lost Caves of St. Louis or something along those lines. The understanding of really what the caves were like under the city of St. Louis is fragmented at best. And that's unfortunate because I think it was probably quite an amazing thing to see this sinkhole plain that sat right at the confluence of two of the major rivers on the planet and what was going on there geologically. If you want to see an expression of that in today's world, go to a place like Carondelet Park and look at the sinkholes that are there. And that's what all of St. Louis, South St. Louis was like that. It had that frequency or that intensity of development.
I think a comment on that. The reason why St. Louis, they have all the brewers here is because they stored the beer in the caves. Isn't that correct?
Right. Well, I don't know about that, but they did store the beer in the caves.
That's why. That's why they have all the brewers here.
Mm-hmm. All right.
Thanks again.